Welcome to the Energy Central Power Perspectives podcast, the show that brings leading minds from the energy industry to discuss the challenges and trends that are transforming and modernizing our energy system. And a quick thank you to H2scan, our sponsor of today's show. Now, let's talk energy. I'm Jason Price, Energy Central podcast host and director with West Monroe, coming to you from New York City. And with me, as always, from Orlando, Florida, is Energy Central producer and community manager, Matt Chester. Matt, today we have episode 2 in a 3-part series featuring hydrogen sensors and detection technology, a topic that may have flown under the radar for too long by our listeners. If anyone missed episode 1, can you give us a quick summary of what we talked about?
Sure, Jason. We were fortunate enough in the last episode to have a conversation with H2scan's Bill Whitehead and Leon White, where they taught us all about the hydrogen gas detecting sensors that have been standard in power transformers for many years. But despite those sensors being commonplace, what we learned from them was how compelling this moment really is for the technology and for the industry, specifically due to things like the supply chain challenges for transformers, newfound threats to grid equipment, and the long-term view of growing power demand, distributed energy, and more. So I'm excited to hear how today's guests will be able to build upon this background of the hydrogen sensing sector and what other critical factors have been operating just under our noses this whole time.
Yeah, thanks, Matt. And that definitely was an episode not to miss. And now we're lucky to welcome to the podcast one of the colleagues of Bill and Leon's at H2scan, and that's Jeff Donato. Jeff is the sales director of safety products, bringing with him nearly 3 decades of experience in the industrial battery industry, specifically in safety and compliance products in utilities and other key sectors. Jeff is joining us today to talk about a different use case of hydrogen scanning and how H2scan is leading the industry in utility equipment performance, safety, and detection. Jeff Donato, thank you so much for joining us today on Power Perspectives.
You're welcome. Glad to be here.
So let's dig into this. Jeff, we mentioned that we previously chatted with Bill Whitehead and Leon White about the trends in hydrogen detection sensors for transformers. That part of H2scan's business is directed at monitoring system health, whereas what you deal with more is hydrogen detection for safety. Can you give us a broad overview of the specific applications in which these safety applications come into play?
Absolutely. So normally when you talk about backup power or standby power, when it comes to emergency power systems, generally those systems can operate on a variety of different technologies. The majority of them have to do with lead acid batteries, but we also have other technologies that emerged in the marketplace, such as nickel cadmium and lithium and other different emerging technologies, some of them gassing, some of them non-gassing batteries. But the majority of batteries out there actually gas hydrogen under certain circumstances, some of them during normal charge operations and some of them that are not necessarily during normal charge operations, but rather when you're in an overcharge situation, which also could lead to thermal runaway, which also has dangers of its own when it comes to hydrogen ignition and fire and such. So from a safety aspect, really what we're trying to accomplish is to keep hydrogen levels under the lower flammability level or lower explosion level. Those words are typically interchangeable, and making sure that we maintain a safe environment no matter what the circumstance, whether it be a best case or worst case scenario.
All right, that's helpful. So then take us into the regulatory and code requirements side of things. In other words, are these specific regs or codes required as part of hydrogen detection? More importantly, is installing them require this type of work?
Interesting question. So when you're talking about battery codes, they typically have a minimum battery size or system size to comply with a code. And that really depends on the battery technology. So with lead acid batteries, it starts at 70 kilowatt hours. And 70 kilowatt hours is roughly equal to about 50 gallons of electrolyte. This is like a minimum requirement to have to comply with the code. Of course, we're talking about codes that are adopted by states or countries that recognize International Fire Code and National Fire Protection Association. And so when it comes to these codes, the International Fire Code, that would be Section 608 in some older versions and Section 12 in newer versions. And then on the NFPA side, National Fire Protection Association, Association, that would be NFPA 1, Chapter 52, or if you're working off a newer code, it would be NFPA 855, which we've all heard about development of that standard in the industry. So in these type of regulations, they do specify that you must keep hydrogen below 1% of room volume. And so having said that, that's basically the entire room minus the equipment, and the remaining space in that room has to be kept below that 1%. The lower explosive level or lower flammability level is going to be at 4%. So we need to stay within that gap of being non-explosive and explosive. So we operate in a very safe range. So you mentioned, does hydrogen detection, is it actually called out in the code? It starts with the risk mitigation plan or risk mitigation program. And the analysis that you do in that program determines what kind of airflow you have in the site, what kind of hydrogen is produced as far as the levels of hydrogen. And then it also will allow you to choose what your mitigation plan will be. So if that's continual ventilation, you might be able to satisfy it that way. In cases in where it may not be so easy to maintain, you might put hydrogen detection with that so you can actually prove what your levels are. And then there's also other safety devices that you can connect to the hydrogen detection system to be able to enunciate or to be able to activate actions such as exhaust fans and things of that nature. If you do use hydrogen detection, then the code is fairly prescriptive of how you need to set that up. So knowing what those codes are with the hydrogen detection system and its operation is going to be very important for you.
So Jeff, make this a bit more, let's say, relevant for our audience in the sense of the market you address. So when you're out in the field, who is actually using these sensors? Who is actually your customer in all this?
So using the sensors, we find different market segments, such as uninterruptible power systems, such as UPS systems that have the 70 kilowatt hours or greater, and also have batteries that give off-gassing, such as lead-acid batteries. We also find utility sites, such as SCADA systems, substation systems. Some people call them station batteries. Those batteries are typically a flooded battery or a vented lead-acid battery, as you call it, and they continuously vent hydrogen. And those type of systems definitely need to make sure that the hydrogen mitigation plans are in place. And then also in telecom sites, you'll notice that you have the very small cell sites that may have valve-regulated lead-acid batteries, as well as the big central offices that may have flooded batteries or vented lead-acid batteries. And in both cases, the mitigation programs need to be created and followed. And then you have another segment that is outside of emergency power, and that's more of energy storage. We see those sites are mostly lithium batteries, and we feel like there's probably going to be more monitoring requirements in the near future that will exist for lithium batteries. Right now, since it is a non-aqueous battery, they don't gas under normal operations. And so in this case, right now, they're not really focused on hydrogen sensing for those applications quite yet, but based on the power density that's being deployed out there, we might actually see that come up in the future.
I'm glad you brought that up because, lithium batteries captures all the headlines these days, but all the work you're doing is in lead acid batteries. So tell us, what do you see as the future for lead acid batteries in terms of playing a role here, as well as the role of H2scan as more of the technology moves towards lithium batteries?
I think everybody in the marketplace will agree with me that lithium batteries definitely are emerging, but lead acid batteries are not going away, and neither will nickel cadmium batteries based on specific application. In those technologies, when we talk about lead acid batteries and also nickel cadmium batteries, which is typically used in utility applications, lead acid batteries typically have a much lower price point than the other technologies. So when we're talking about sites that want lower deflagration possibilities, so lower potential for any kind of accelerated burning risk or anything of that nature, they'll use more of a lead acid battery type. They'll also use those in medium to low rate applications, because when you start talking about other technologies than lead acid, you start coming into a much larger price point. So you have to make sure that you're getting the characteristics that battery has to offer in the correct application to be able to support that price point. And so we really see that there are still a lot of UPS applications, a lot of telecom and utility applications primarily use the lead acid battery because of the load profile and its price point. Utilities is pretty much all of the vented lead acid batteries, or what we call flooded batteries. You see a mix of flooded batteries and sealed or valve regulated lead acid batteries in the telecom and in the UPS markets.
That makes sense. So lead acid batteries certainly aren't going anywhere. Let's go back to safety for a moment. When it comes to ensuring safety of their systems for the risk of hydrogen, are sensors the only strategy used, or are there alternatives other technologies that people apply? And are there instances where those alternatives are insufficient and require the use of sensors?
Definitely, ventilation is used as the primary line of defense in a lot of applications when it comes to controlling hydrogen. And that would be anywhere from forced ventilation to basically organic ventilation through just open spaces. But in those areas, you're using ventilation, which obviously you have to, based off the risk of building up hydrogen, you have to follow certain guidelines or standards when it comes to sizing and creating those ventilation systems. There is a document out there called the IEEE 1635 ASHRAE 21 document. It's a joint document between IEEE and ASHRAE. And what it basically does is it gives you a way to calculate the amount of hydrogen that a battery will produce based on also the amount of hydrogen that could collect in a specific space based on certain factors and certain conditions. And so in this case, it'll give you the ability to calculate that 1%, whether or not that particular battery you're sizing for is in float charge, boost equalized charge, the initial charge, or in a very extreme case of, say, charge or runaway. And it also gives you the 4% calculation to get to the lower explosion limit. So that document is used in a lot of risk mitigation plans because it does get very specific. Now, things that can go wrong, even with these plans in place, you could have a situation where you're not wanting to hyperventilate a site because you want to be more efficient. So maybe you don't want to run your fans all the time. And so you'll need a device to be able to recognize when fans should be run. A lot of this has to do with companies trying to meet a carbon footprint or having some energy efficiency models. We found sites would do efficiency audits, and those that are actually running fans at full speed will fail their efficiency audit. We also find that fans are mechanical devices. Current code says that a fan should have a 2-hour backup power supply on the fan. So if you don't have a 2-hour backup supply on the fan, then you probably want to build into your risk mitigation program that you have some sort of monitoring in place to actually monitor the effectiveness of your ventilation system. So if you have a power outage or if your ventilation fan tends to fail or is not running the way it should, then you have another device out there for detection, protecting the facility.
That's important. So I'm going to ask you a question. Perhaps it's a bit unfair, but let's try it anyways. In our industry, it's all about discovery. And it's really along the lines of if more people were aware of the ability to effectively and affordably detect hydrogen, then what new opportunities might that unlock at utilities that had assumed doing so was either too high or simply too risky?
That's a great question. I'm going to answer that in a little different angle, if you would. So traditional hydrogen detection systems are very labor intensive. And when I say that, it means that when you put them in, they have a specific life cycle that they have. So in other words, they only last so many years. And then also, depending on the technology that you're installing, they may need maintenance over a period of time, every so many months, let's say. I'm going to talk about H2scan's legacy products in comparison rather to our current newer products. So if you bought a catalytic bead sensor, that is a very traditional type of technology. You find that in a lot of sites. That particular technology will last anywhere up to between 3 and 5 years, and it needs calibrated roughly every 6 months, and that's to keep it accurate. New technologies today are not catalytic beads, they are actually solid state. So that means that catalytic beads actually will wear out over time, be consumed by the environment. Solid state technologies cannot be consumed by the environment. It actually remains operational for a longer period of time. Also in the newer technologies, you have auto calibration features, whereas I mentioned in the old technologies, you have to calibrate those every 6 months. Now the systems auto-calibrate themselves. And so it still goes through a calibration process, but you no longer have to run the truck rolls or create a new contract for calibration of the systems, like a maintenance contract. So that overall lowers the cost of actually owning the equipment. The total cost of ownership of the newer style of sensors versus the old style of sensors is a lot lower than it would be in owning the traditional older technology. So the cost savings in the maintenance and the overall total cost of ownership, combined with not having to run fans all the time and letting your hydrogen detection do its job by help mitigating that risk, will lower the cost in a few different areas.
Yeah, and certainly for utilities, having the lowest O&M possible is the name of the game, right?
Absolutely. The more risk that we can mitigate, as well as detecting abnormal conditions and detect failure before it actually happens, or mitigate a risk is always going to be better for the consumer.
Yeah, for sure. All right. So Energy Central is made up of energy and utility professionals. It's the utility and power companies that are listening in today. So share with us, say, some specific use cases where power companies were able to achieve goals they didn't necessarily think were feasible before leaning into hydrogen detection.
Well, a couple of goals relating to the technology is that the goal of energy savings within the site, being able to control that atmosphere where you're not having to run fans constantly, is one. So that means that you have a secondary backup that's actually telling the primary ventilation system what to do. So that's achievable now. The second thing is the life cycle. Typically, sensors do not last the life cycle of a battery, and especially in utility applications where most of the vented lead acid batteries, or sometimes as they call flooded batteries, typically the sensors don't last the length of time that the batteries will last. That's all been turned around now so that the sensors will actually exceed the time the battery will last in its service life, which is a big obstacle in the past. Having to have another wearable item in the middle of your system is always not optimal. So that problem has been solved. And then the third problem has been solved is communications. So in a lot of sensing prior to this generation of sensing, you've only really had alarm points set at 1% and 2% in the substation. Now you can detect the actual percent of hydrogen through Modbus communications, and the communication can go straight to your SCADA system without actually going through another data collector or controller. So now you can write as many rules as you want to within your software running the system. So you could say, I want an alarm set point that is below 1%, so I know when something is actually in an overcharge situation before it becomes a hazard. Now I can actually detect whether something is on equalize or something is going on inside the site that is not necessarily an emergency, but something I want to know about. And also being able to relate that to other detection that you might have going on. So if you have, say, for instance, CO detection inside of your sites, you might want to know the hydrogen levels inside that site in case the hydrogen is actually poisoning the CO detector. So there are a couple other situations you might consider that we're actually able to do now by being able to detect lower levels of hydrogen and report on that within the substation that you haven't been able to do before.
All right, Jeff, so I've thrown a lot of questions at you. And at this point, before I give you the last word, at this point, we're going to go into what we call the lightning round, which is a series of questions we'll ask you, and you have one word or phrase to respond to. And it gives us an opportunity to learn more about you, Jeff Donato, the person, rather than Jeff Donato, the professional. So, Jeff, are you ready?
I'm ready.
Okay. Best gift you ever received?
Best gift I ever received, I would say probably my children was the best gift I've ever received in my life. I'm really a family guy.
Ideal vacation spot?
Anywhere warm.
Any hidden talents or unique hobbies you'd like to share?
I like to do my own construction projects around the house. Very big into home improvement.
Who has been your biggest role model?
I would say I'm a faithful guy, so I would say in this case, my faith in God, pretty much my role model.
What are you most passionate about?
I am most passionate about success in my family, success in my career, and also serving in my church.
Nicely done, Jeff. As a payoff for navigating our lightning round, it's time for you to sound off with the open mic to give us the last word of the episode. What would you like our listeners to take away from today's conversation?
What I would like the takeaway to be would be that when you're looking at the codes and standards, realize that they change quite frequently, like every 3 years or so. When we're working on an IEEE document, for example, it takes us quite a bit of time to actually put those together. And it also takes the code writers quite a bit of time to put model codes together. And because of this, based on adoption times within the states and local municipalities, you might find that there are areas working on newer versions of the code and others that are working on off of older versions of the code. And also notice that best practices and codes don't always align either. So the risk mitigation program is pretty important to be able to know how you're going to do something based on today's technology and not about a standard or a spec that was written years ago and you're just re-implementing. So my challenge to everybody today would be to take time to read the new codes and standards, take time to research the new technologies that are out there, make a better case for using new technologies to make your lives easier. Very similar to the NERC requirements for battery maintenance, where monitoring actually will cut down on some of your tasks. You could do the same thing with safety products as well. Some of the safety products today, especially in hydrogen monitoring, can really help you with making sure that your you're protecting your assets and also protecting your people.
We really appreciate your thoughtful responses today and can certainly tell the interest and desire to pass this knowledge on to our listeners. So thank you again for really sharing your insight with us all. Jeff Donato from H2scan. Jeff?
Thank you. Thanks for having me today.
For sure. And we also want to give a shout out of thanks to the podcast sponsors that made today's episode possible. Thanks to H2scan. H2scan Corporation specializes in the design, development, and manufacture of industrial hardened hydrogen sensors. The company was founded in 2002, based in Valencia, California. H2scan's products are used in various utility industrial applications, including power transformer health analysis, substation battery room safety, and process gas stream monitoring. The sensors and analyzers are designed to provide accurate and reliable measurements of hydrogen concentration levels for 10 plus years without requiring calibration. H2scan's technology is based on advanced materials science, and the company is committed to providing innovative solutions to help customers improve their processes and operations. And once again, I'm your host, Jason Price. Plug in and stay fully charged in the discussion by hopping into the community at EnergyCentral.com. We'll see you next time at the Energy Central Power Perspectives Podcast.